In this problem, we're going to find out the components of the electric field due to two charges. So let's say you have two charges and two charges. One is Q2 and the other is Q1. The magnitude, the Q1 is negative 1 microcoulomb and Q2 is 5 microcoulomb. And the distance from the origin is given. This is at a 4 meter distance along the x-axis and this is 3 meter. Now what we have to find out is what's the x component and y component of the total electric field at the origin. So due to both charges, we have to find out the x component and the y component. Okay, so this will be x component and this will be y component. So you have to find out the x and y components due to both charges. Okay, so first thing, let's start with this charge Q1. The Q1 is negative charge, and we know that electric field due to the negative charge is always towards the charge. So this will be the direction of the electric field due to the Q1 charge, and I'm going to draw it here. I'm going to use the green one. So this green one, this one represents the E1. This is the E1 is the electric field due to charge Q1, and this is the direction. This is the direction now. The Q2 is a positive charge. So what does that mean? The electric field will be away from the charge, and at this point, so first let me draw so now also find out the distance as well. So this is 4 meter, the 4 meter distance, and this is 3 meter distance. So this distance, the distance from the origin to this will be equal to square root of 4 square plus 3 square, which is equal to 5 meter. Okay, we know the distance now. Now let's find out the direction of the electric field. As this is a positive charge, the direction will be away from the charge. I'm going to use a different color. Let's use the purple one. So due to this will be the direction of the electric field due to the charge Q2. I'm calling this is an E2. Now what you can look at, the E1 has only x component. This is the x-axis and this is the y-axis. E1 has only x component, but E2 is at some other angle, so it has two components. We can find out the components. This will be y component and this will be x component. Okay, so let's find out the components. In order to find out the components, we're going to call this angle as an angle theta. Okay, as this angle is theta, as this angle is theta, this angle will also be theta as well. This angle will be theta. So this will be E2 cosine theta, and this one will be E2 sine theta. So now you can see now the electric field E2 has two components, E2 cosine theta and E2 sine theta. Now let's find out all the values now. Okay, but we need to know the angle theta as well. How do we find out the angle? If we look into this triangle here, this triangle, then cosine theta cosine theta. The cosine theta is base over hypotenuse. What is the base value? The base in this case is, this is the base 4 and the hypotenuse is 5 meter. So we can write down 4 divided by 5. The same way we can find out the sine theta. The sine theta is the rise or perpendicular, this distance, rise over hypotenuse. In this case it will be 3 over 5. Okay, so this is 3 and this is 5. So we found out the sine and cosine theta. And now let's calculate the electric field now. The electric field due to charge Q1, which is E1. The E1 value is K Q1 over R square. R square. And R in this case is, this is the R. Here, whenever I write down this one, this means the distance between the charge and this point here, which is 4 meter. So let's plug in all the values. We know the value of K, which is a constant, and this constant is 9 times 10 to the 9. And Q1 value is 1 microcoulomb, 1 times 10 to the minus 6. Here I'm only using the magnitude because we already have defined the direction. Okay, so we do not need to put the negative sign. And R, and the R is the distance between the charge and the point. In this case it is 4 meter. So we have 4 square. So if we plug in all the values, what we get is 562.5 volt per meter. And the direction is positive x-axis. Positive x-axis. This is the direction. Okay. Now let's find out the magnitude of E2. E2 will be again given by K Q2 over R square. K is again a constant, which is 9 times 10 to the 9, and Q2 is this charge here, which is 5 microcoulomb charge. 5 times 10 to the negative 6. 1 microcoulomb is 10 to the negative 6. R is the distance between the charge and the point, which is 5 meter. So 5 square. If we solve it, what we get is E2 is equal to 1800 volt per meter. That's the electric field, the value. Okay, so we now know the E1 and E2, but this E2 is at some other angle. We need to now find out the components. The x component, E2x, E2x is the x component of the electric field E2. Let me write down here x component of E2, and this is equal to E2 cosine theta. So now let's find out E2x now. E2x. We know now what is E2. We know this E2, which is 1800. So 1800 times cosine theta. Cosine theta value is 4 over 5. So we have 4 divided by 5. If we calculate this one, we'll get 1440 volt per meter. Now let's calculate the E to Y component. E to Y component. E to Y, which is Y component E2. And what is that? This will be E2 sine theta. E2 sine theta. Let's plug in all the values. E2y. E2 value is 1800. See that the E2 value, the value of E2 is 1800. 1800. And sine theta is given by 3/5. This is the value of sine theta. So sine theta is 3/5. If we solve it, what we get is 1080 volt per meter. Okay, now let's take a look at this diagram here. Along the x-axis, we have two components. The one is E1, the other is E2 cosine theta, and they are in opposite direction. But along the y-axis, we have only one component, which is E2 sine theta. So let's find out the total electric field component along x-axis. ETX. What does the ETX means? Total electric field along x-axis. This one will be equal to E2 cosine theta, E2 cosine theta minus E1, and E2 cosine theta value is 1440 minus 562.5. If we solve it, what we get is 877.5 volt per meter. That's the total electric field along the x-axis. And remember, this direction is negative x-axis. It is along negative x-axis. Why is that? Because this component is greater. E2 cosine theta is greater than E1. So the resultant field is along the negative x-axis. Okay. So now let's find out E2, ETY. ETY, the total electric field along y-axis. Total electric field along y-axis, and it has only one component. We already find it out, which is this value. It has only one electric component, so 1080 volt per meter. Okay, but sometimes, so we now know that this is the total x component and this is the total y component. But if I ask you what's the total electric field, the magnitude, so if I ask you to calculate the total electric field, then how can you write it? How can you get it? The total electric field now the ET will be now given as ETX square plus ETY square. And we know now the value of ETX. ETX value is, this is the ETX value and this is the ETY value. We plug them together, then what value you will get is 1392 volt per meter. And again, we also can calculate the the angle as well. Let me explain this one too. So this is, let's say this is the total, so we're calling this as a E total X component, and this is the electric field Y component. So the total electric field now will be at some other angle here. The total electric field will be at some other angle, this angle. Look at this, will be the total electric field. This is the total electric field. And this angle we can call as a phi. Remember, this theta and phi is different angles. This is the phi is the total electric field which is at an angle with respect to x-axis. Okay, so this theta and phi is different. So the phi gives you the in which direction is the total electric field from the x-axis. That is the total, the phi. How we can find out the phi? Phi we can find out by doing tangent inverse ETY, the y component, divided by ETX component. Okay, so if we solve it, tangent inverse, what is the total y component? The total y component is 1080, and the total x component is 877.5. 877.5. Let me plug into my calculator and see what I get. 1080 divided by 877.5 and shift tangent inverse. The angle I got is phi is 51 degree. So this gives you the, that means the total, the resultant electric field, will be at a 51 degree angle. So if you have any questions regarding this,